Hello all, welcome to the show. I'm Gus Gagliardi and this is Firecode Tech. On Firecode Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Firecode Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Hello all, welcome to Firecode Tech. This is episode 45. On this episode, we're talking about fireproofing. It's our first ever panel episode of Firecode Tech, and on this episode, our board for the panel consists of Phil Mancuso and John Dalton. Phil and John are career professionals in fireproofing and passive fire protection. So in this episode, we dive deep on what are the codes and standards around fireproofing, what are the testing means and methods, and how do they differ across different occupancies and hazard groups like commercial occupancies, tunnels, and also petrochemical facilities. This episode was really special, and John and Phil are very passionate about their industry and promoting people getting involved with passive fire protection and fireproofing. So I hope you enjoy. Don't forget to follow us on social media and subscribe so you never miss an episode. Well, Phil and John, I just want to welcome you both to the podcast and say thanks for coming on.
Thank you for having us.
Yeah, thank you for the opportunity.
Awesome. Well, for the listeners, this is the first time we've ever done a panel discussion. And so generally how I kind of start these podcasts or interviews off is trying to get a little bit of background about who we're speaking with to give the listener a way to key in and have some knowledge of the person's history. But yeah, would you both mind giving a little bit of exposition on how you found fire and life safety, or how you kind of got into your roles now?
Sure, I'll go up first, I guess. So it kind of fell on my lap, I guess you could say. The company itself, actually, that I've been working for about the past 20 years, I actually started in my teenage years, just working during the summers, more like filing paperwork and different things like that. And over time, they had an opening in their technical, and I figured I'd take a temporary job, see how it works out, and here I am. There was a lot of family and so forth in the company as well, kind of working in various areas, so it was kind of an easy transition for me, and the rest is history.
Very nice, very nice. Yeah, it seems to be a very common theme in the industry is somebody has some exposure to fire and life safety, and then it turns out to be a good career move. So it's interesting to hear. It's a pretty common theme. John, what about you? How did you find fire and life safety?
Yeah, it kind of landed on me in a strange roundabout way. So I started working with the company in 1999, and I was an R&D technician there for about 2 years or so, and I was doing a concrete pour because we have an admixture site, and a bucket landed on me, and I picked up to look to see who had dropped the bucket, and there was a gentleman up there on the back of a concrete mixer, and he and I got involved in a shouting match about his work habits and dropping buckets. And about 2 days later, I get a phone call from this guy who I didn't know at the time. Said, "Here, I hear you're an R&D technician with some potential. I have an opening in the fire protection technical service team if you want to come down and have a chat." And I had no idea who he was, and until I rounded the corner into his office, and there was the guy I had been having a screaming match with like 2 days prior. And it just kind of started from there. Very similar, I think, pathway to Phil. Like I started pretty much sort of just answering the calls and like taking information and then going finding out where the answers were. And then, over time, as people retired or moved on, I just kind of got promoted and moved up in within technical service, and sort of I'm the technical service manager now in a role similar to what Phil had, obviously in competing companies for about the past 10 years or so.
Wow. I can't believe it literally fell onto you. It hit you over the head with the job. I've never heard that one before. So that's interesting to hear that, John. Well, so I wanted to, preface our conversation with today's topic centers around fireproofing and, diving into this topic. So for those who, mm, you know, for those who might not have much knowledge about what this term means, in both of your estimation, like broad overview terms, what is fireproofing?
I'll jump on that one, Phil, because you took the first
Yeah,
one
go
if you
for it.
want. But fireproofing is, in our terms, is a product that you spray, roll, trowel onto structural steel or concrete in order to give it a fire resistance rating. We don't actually make anything fireproof as such, but it's the fireproofing that you see sprayed onto structural steel in buildings. You see it on the underside of tunnels. You see it a lot in petrochemical facilities, just to protect the steel, to keep the building upright, to keep the building square so that the fire stopping products can work, to support the sprinkler pipes. There's a lot to it. That's probably it in a nutshell, Phil. I don't know if you've.
Yeah, it's. I mean, it's pretty straightforward. It's nothing new there, but yeah, it's basically a layer of insulation that you apply to steel. It can be applied in different ways. It could be like a cementitious type material, or a paint-on material, or mechanically attached material. But ultimately, its use is to keep the limiting temperatures down to a specific number, and or a specific value, to keep the steel from hitting a point of collapse.
I see. I see. Well, that's very interesting. So, I immediately after John contacted me, I was like, I gotta figure out the codes and standards around this topic, or try to find somewhere in the code where it's specifically required. But I want to get your perspective before I just run my mouth for, my code nerd business. But when is this fireproofing required? I can understand there are probably many situations in which you might need these systems to give a specific fire rating to different materials. But yeah, in either of your estimation, when are these systems utilized?
It's entirely code driven. The everything is in the modern international building code, obviously an ever changing code, but most of what's in there has been historically similar over the years, with various minor changes and tweaks over the years. But for the most part, what you'll find in what we're dealing with is chapters 5, 6, and 7 of the code, and the fire protection requirements are all based on the use and type of the building, the different various aspects that are all put together, and it all kind of falls onto one table in chapter 6 that determines the hourly fire resistance ratings.
Very nice. Yeah. Yeah. There's that structure fireproofing, I think, is the most common area in which I've seen it in my career in a variety of buildings. But you know, I guess depending on which version of the building code you're looking at, there might be more or less. I was just looking through the 2015 edition, and I found a couple areas. I do a lot of hanger work, so at the company I'm with now, so cementitious spray for columns and hangers is fairly common.
Mm-hmm.
So yeah, I appreciate you talking about that kind of when piece of fireproofing.
Right, and one thing to keep in mind too is that even though everything's kind of backed by the international building code, is everything all kind of walks down to the state level and then the local level. So it's all interpreted down the way, depending on who wants what. But it's, again, we're dealing with life safety here, so we're all trying to do the right thing.
Yeah, definitely. Yeah, that's such a great conversation point. I always try to express to people, when they come for solutions or asking when a system is required, I say, do you know what you're dealing with in your jurisdiction? Because if you don't, I can't even begin to answer your question. So I appreciate you touching on that point of the jurisdiction and the local adoptions, because it's so important. But so I wanted to further go on in the discussion, and you guys touched on a couple of different types of these fireproofing solutions and kind of what the intent is for them. But I'd like to speak more specifically about the different types of solutions. You said if you can trowel it on, if you can spray it on, but I was taking a look at a couple of your um, companies' websites, and it seemed like there's kind of like four broad types of solutions. But yeah, I'd love to speak about those more detailed in
Sure,
specific.
I'll
John, you
swing at
want to
that
take this
one,
one?
Phil. There are sort of two main types of fireproofing. There's the sort of more traditional, which is cement and gypsum, or gypsum mixed in a bag with a or as a binding agent with a pumping aids and mold inhibitors and a few other bits of foo dust and stuff like that. You mix it with water and you spray it onto the steel. That's sort of by far and away has been the most common traditionally around the world. Um, it's been around in various forms for quite some time, and there hasn't really been a huge development in that over the last 30, 40 years or so. And then I suppose the younger brother of that um, is the intamescent fireproofing, which is often sort of referred to as intamescent paint, which is a product that expands and forms an insulating char when it's exposed to heat. So probably the two by far and away the most common types. We also see board products. So, for instance, gypsum wallboard is an excellent insulator for the steel. There are specific mineral fiber type boards that are also used, although they're much less common than, say, the product that you spray comes in a bag mixed with water, or the intamescent. They're by far and away the biggest. They would probably account for 95% of the fireproofing sold around the world.
Right.
And then there's various different, like
Oh
each
wow,
segment can be
yeah,
broken down further depending upon the the environmental conditions in which it's going to be exposed. So if you have an oil rig in the North Sea that's going to be exposed to really severe winter weather for 9 months of the year, you typically will have a really durable epoxy type intumescent that can withstand a lot of environmental degradation. Or if it's an interior conditioned office space where it's hidden behind a wall or above a drop ceiling, that's a much less robust product. And then everything in between.
wow,
So
that's
you
interesting.
could probably break it into seven
Yeah,
or eight different product type categories, and then most companies will have products in each segment.
huh. Wow. I guess I spend so much time focusing on the interior aspect of the buildings that I don't think of that fire rating on these exterior pieces of equipment and or structure that might take a beating. That sounds like a pretty harsh environment, on the North Sea with the petrochemical facilities. It sounds like, yeah, you need a different tool for that application. That's pretty
And the
interesting.
fires, yeah, the fires that they're going to be exposed to are much less severe. So the product on the interior of the building, it's going to be exposed to an ASTM E119 type fire, which is a relatively slow burning fire. It's typical to the ISO 834. And it's not, it's been around 100 years, mimics how wood burns, as opposed to a petrochemical fire where you've got this huge initial blast of heat, reaches 2000 degrees Fahrenheit after 5 minutes and maintains that temperature for as long as your rating is. It's a much more severe fire. Similarly, fireproofing products used in tunnels, that they have a different fire test curve, which is probably the most severe of them all. It'll reach 1350 degrees Celsius, which is an extremely severe fire. And so there is a huge variety of pathways to achieving a fire resistance rating depending upon the type of fire and the type of exposure of the product.
Wow. Yeah, 1,300 degrees Celsius is ripping hot. That's crazy hot.
Toast your marshmallows on that.
Yeah, toast your house on that. But no, so you talked about a couple of ASTM standards, and that's probably something that is hypercritical for these applications are the listing agency standards in which these systems are tested. Would you both mind speaking about a couple of these more common standards that are really important for fireproofing and for people to understand when trying to apply these solutions?
I guess I'll take that one. There are various standards. As John was alluding to before, I'll stick with just the standard ones. But there are various tests that can be used throughout the industry, depending on the material that's being used. The two most common are going to be the ASTM E119 or the UL 263. That's that cellulosic fire curve that John was alluding to earlier. And then once you start getting into the hydrocarbon, you get into UL 1709, which is a much more severe test. On top of that, there are other various tests as well that can be done for the petrochemical end, jet fire, blast explosion. There's all different types of physical property tests and things that the materials have to withstand, weathering. We can go on and continue to talk about that, maybe on another time. But you have tunnels. That's the RWS, the Rick Waterstadt test. It's all different types of all various things, depending and tests depending on what the end result needs to be. But the majority, as John was mentioning earlier, I think the majority of what we're dealing with here is going to be primarily the cellulosic end, hydrocarbon end. The hydrocarbon end has been changing a lot more recently. I would probably say more or less the commercial aspect of the business, but just using, kind of moving toward different product types that are a little bit more durable. But those are your primary factors that are used in terms of those types of tests.
Yeah, wow, that's interesting. Yeah, I've never had the opportunity to work on a project centered around a tunnel, but it seems like such a high hazard and such stringent applications, especially
Right.
seems like the EU takes tunnels extremely, extremely
They
serious in
do.
their fire and life safety application.
They definitely do.
But yeah, I was talking to, go ahead.
No.
No, I mean, I was just, you'd mentioned it, like, so we do a lot in tunnels. Like, tunnels are one of our things, and tunnels are one of those buildings. Like, every fireproofer or every engineer, sometimes you're driving around or you're walking about, and you see a building that you worked on, you think, yeah, that was one of mine, or I did that, we did that. Tunnels are kind of like that. They're just so big, like they're huge civil engineering works, that when you're walking down a tunnel and you're looking up at your fireproof, and it's one of those sort of career defining moments where, like, no matter what part of fire protection you're in, whether it be sprinklers or smoke movement or whatever, it's like a signature thing. Tunnels are just, they're awe inspiring to work on, but they're one of those things because it's a difficult time in terms of the tunneling fire protection world, because there's a lot of moving parts to it. Especially with sort of the development of electric vehicles and autonomous driving and stuff like that. It's kind of fraught with risk, and because the dangers are so great in tunnels, it is a kind of one of those ones where you're always checking yourself. You're always thinking, did I do the right thing on this? Like, getting somebody else to look at your work. That review is big on the tunneling side. Buildings like a 5-story office block, they're very similar. They're all kind of the same, whereas tunnels are ones that give you pause.
I agree, and I agree exactly with what John just said. And when it comes to the commercial structures, you pretty much have standard UL designs. Sometimes you move off of those a little bit in terms of engineering judgments, but it's all very straightforward. Petrochemical takes it a step further, but tunnels, from the initial design phase to the project start and completion, could be 5-10 years. Sometimes with some of these projects, and the amount of paperwork, the amount of tests, application instructions, and just dotting every I, crossing every T. Everything that's in there is just very extensive. And I agree with what John said. Is you look at it and then you see the final result. It is definitely awe-inspiring to actually see it once it's all said and done.
Wow, that's awesome. I love hearing about that from you guys. About I have some projects like that in my life, but it's uh, the only thing I would compare it to in my experience is that hangar work. Such a greater impetus for fire and life safety, and so much specific design knowledge where you have to really understand what you're doing. Like I'm sure you guys would say, you can't just walk into tunnel fireproofing if you don't have significant experience in it. You just would get your lunch eaten. So it sounds like that is your guys' experience with tunnels, and I love hearing about that because kind of the most severe and biggest fire and life safety challenges are the most difficult and the most rewarding when done right. So that's really neat to hear you guys both talk about those.
And we like our standard fire curve is the ASTM E119, and we do, between our companies, we've probably done thousands of fire tests, and it's the same fire test all the time. It's a standard size furnace, standard size beam. You might play around with it a small bit in terms of the loading on the beam or whatnot. Tunnels, it's generally speaking a different fire test for every project. Right? Any tunnel of any size will want their own fire test because their concrete is going to be slightly different, and that becomes a thing. And you're sitting in the fire test lab, and they turn the gas on, they turn the heat on, and then all of the work that you've done for years designing your system and looking for it, it's kind of, you're just sitting there waiting. And I often think it's like when my son was born, I'm just kind of pacing back and forth, kind of waiting for something to happen. And you're just sort of looking at the monitors and you think, oh man, yeah, this is, but it really is sort of a stressful 3 or 4 hours that you're walking back and forth, peering into the furnace, seeing what the thermocouples are reading, and an exhilarating time. Like it really is. I often find that when after a fire test for a tunnel, you just have to sit and just stop and sit down and kind of calm yourself a bit, because you're so stressed out for so long, making sure everything has gone wrong. And there's a saying in our side of the fire protection that, the only way to win is to out-test them. And testing is so important to us and to everybody in this field, that once it happens and it's over with, you're so relieved. You're so, provided it's gone well. Like, there's nothing worse than if it fails with a couple of minutes to go and then you spend all this money and you don't get anything.
Yeah, that's crazy. I can't imagine the stress of having to be in that situation. I've had big acceptance tests before that have felt like that, where you have trouble sleeping the night before and you're pacing in the morning and you're looking at everything and double checking your testing documents. But that's awesome. It sounds like quite a momentous occasion when you pass a test. But yeah, it'd be great to hear a little bit more about that testing process, since it seems like it's so integral into how the business of fireproofing operates.
Yeah. So when we do it, typically speaking, what we will get is like on the RWS or any of them. Like, I mean, are you talking about in commercial construction, or are you talking about sort of on the hydrocarbon petro tunnel type side of things?
I mean, you could just speak to either broadly. I mean, I wouldn't be able to tell you the difference between the applications or the testing, but yeah, and whichever one in specific that you would like to go over. I mean, I have more interest in the tunnel stuff. Sounds very interesting. Or I mean, I don't get a chance to do as much petrochemical stuff, but I'm sure there's listeners who have experience in that too. So whatever you'd like to go over, John.
Phil, I mean, if you want, I'll take the petro and RWS. If you want to take the commercial,
Sure, go for it. You can start.
Okay. Well, so the I, Phil will touch on it a bit, but generally speaking, when we do an E119 type fire test or something like that, we will go to somebody like Underwriters Laboratories or Intertech. They're the two big players on this field in the United States and Canada, and then maybe go to Warrington or Effectus in Europe. And those fire tests, the commercial ones, are fairly straightforward. You don't really see a lot. The ones for the the hydrocarbon, the jet fire type tests, they are visually very spectacular. So if you can imagine, you have a steel box about a meter square, and it's positioned 60 feet away from a flamethrower, I suppose is probably the kindest way to put it. And you fireproof it, you thermocouple it, you're trying to make sure that the temperature on the backside doesn't exceed a certain temperature, the temperature on the steel itself doesn't exceed, typically speaking for us, it's 1,000 degrees Fahrenheit, 538 C. That's the temperature at which steel will begin to lose its ability to carry the load. And once it begins to lose its ability to carry the load, it curtains really quickly. Once it starts to soften, it will be gone within a couple of minutes, right? And if you've ever seen the aftermath of steel in a full-scale fire test that's behaved where it badly or hasn't gone well, it is amazing how deformed it becomes. It is just a big U shape hanging down between the supports, or it is snaked. And so on the jet fire tests or the RWS tests, these are huge samples. They're visually very arresting in that you have some guy goes over with a lit rag or something like that, lights the gas, and then within a second, this gas is shooting 60 feet across the test area, and it's impinging upon your sample, and it'll just blast away at temperatures in excess of 2,000 degrees Fahrenheit for as long as you can get it to go, hours, and then you kind of start pacing back and forth, and you're trying to. You can't really do anything at that stage, but it's a very spectacular fire test. It's same with the RWS test. The RWS test is a furnace test, but it's a huge sample. It's 1 meter wide, 3 meters long, curved, like typically you would see in a tunnel, and they apply a load to the top of the curve. You fireproof it on the underside of it. Obviously, you let it cure, and then they light the furnace, close the doors, and all you can watch is the thermocouples. Right. And you're trying to maintain. So on the RWS test, the ability to carry the load is obviously hugely important because you don't want the segment to fall in on you. But in tunnel fire tests, one of the things that it's not really just about temperature. It's you want to stop the concrete from spalling. So when you look at big tunnel fires that have happened, like the Channel fire test between England and France, the Mont Blanc fire, Italy, France, one of the things that the firefighters commented upon after, or survivors did, was that not only was the smoke and the extreme heat dangerous to them, but the spalling concrete. So the spalling concrete, the concrete that's exploding as it's exposed to these super hot temperatures, poses a danger to the firefighters and to the people trying to escape. So we have very different criteria than the E119 UL263 commercial fireproofing. It's not just a case of a temperature race, but there's also various other bits and pieces. One of the things that came about, say, post 9/11 was the ability of fireproofing to withstand the blast. So for a lot of these fire tests that we do on the petrochemical side, we will position the sample in a blast area. They will direct a blast or a blast impact onto the sample, examine the sample, and then light the fire and see how it does after a blast. So we have a very varied type of pass-fail criteria within the fireproofing community. It's not really just very straightforward. There's a lot of stuff going on, and there's no real on the petro and the tunnel side. There's no codified requirements. So a lot of projects will have very different requirements. So certain projects will have, they want to do a blast test, then followed by a jet fire test. But during the jet fire test, they want the fireproofing to be impinged upon by a hose stream, sort of replicating what would happen with rapid cooling and heating that you could expect to see if a firefighter were to come across this situation with his hose. If he hits the extremely hot fireproofing with the water from the hose, will that negatively affect the fireproofing? Will the impact of the water knock the fireproofing off the steel? Will the sudden decrease in temperature and then increase in temperature, will that affect the fireproofing? So it is a very, like, the testing side of it is very interesting, and that's the sort of thing that gets you out of bed in the morning, is that sort of testing.
Wow,
Phil?
that's fascinating to hear about. You talk about the variety of tests and the understanding of the fire science of the different um, type of applications.
Yeah, that was, and there's definitely a lot more involved, as John mentioned, with the petrochemical in the tunnel. But when it comes to the commercial side, it's more or less replicating what you actually have on any given building construction. Essentially, what we do as manufacturers is it's up to us to take a common construction assembly, whether it be a floor or a roof construction, and build that in a furnace at the laboratory. Again, whether that's Underwriters or UL, Intertech, Effectus, Warrington, and so forth. And we're essentially building. I'll speak to the E119 and what we do at UL, being that that's the most common, at least here in the States. We construct, let's say, a floor assembly. Okay, it consists of a metal deck, and what they'll do is they'll put the concrete topping on it, exactly how they would build it on a job site, with the welded wire fabric or anything else that's in there. It's a specific concrete type, density, compressive strength, everything like that is all followed. We have to allow that to cure, and below that, supporting it, there's generally now a 4-beam assembly. It's up to the manufacturer to decide what they want to test, how they want to test it. Thermocouples are put on there to evaluate the limiting temperatures, and a specific thickness is applied. And generally, they'll either test a high, low, or there's some calculations that's done in the background. But this is done with all the different type of materials, whether it's the cementitious or the intamescent. Intamescent nowadays being I would say the more difficult one to deal with in past, just because you're dealing with different aspects of charring and stuff like that, where you don't really run into that as much with the cementitious materials. But essentially, all we're going to do is we're going to construct the assembly. We're going to load it, similar to how a traditional building would be loaded, and conduct that fire test. And it's a simple fire test. Not much really happens during the duration. It's kind of a slow test for the cellulosic. Essentially, the temperature in the furnace, it reaches about 1,000 degrees after 5 minutes, and then it slowly increases up to 2,000 degrees Fahrenheit or 1093 Celsius over the duration of 4 hours, or depending on whatever the final outcome or the expected outcome is. And with that information, the laboratory will take the results, and they will essentially create a fire test, or a UL design in our case. It doesn't sound like it's a lot, but it definitely takes quite a bit to, at least lately, to go from a design stage, coming up with a new product, or and so forth, and kind of deciding what needs to be done competitively, and kind of get in there and do all the testing, and keep your fingers crossed and pass. One of the big things too is actually following the building code, which refers to E119, and making sure that these tests that are being done out there are full scale tests. There's a lot of smaller laboratories or other suppliers trying to come in and testing things to a smaller scale, non-loaded, which unfortunately it looks good on paper, but unfortunately it does not give the end result that's needed to actually meet building code. Been one of the more recent battles that we've been dealing with, thankfully successfully, but the big key here, I mentioned it before, and I'll mention it again, is life safety, and just making sure everybody is getting the end result that they need to meet, whether it's code or whatever's specified for the specific construction.
Yeah, it's very interesting to hear you guys talk about testing because I know how costly it can be to go through some of these testing processes with these big organizations like UL, and so I know that that probably only adds to the duress of witnessing some of these tests and kind of formulating a plan and going through all these. I imagine that is a big consideration in trying to get one of these products through listing. Um,
Yeah, it is. I mean, it's probably happened to you too, Phil, and probably to you as well, Gus. But we've had instances in the past where, so when we decide we're going to do a fire test at UL, um, it's a lengthy process. They have to go and pour a concrete slab and put the beams on, and the concrete's got to dry, and that takes about 9 months. And then you spray your stuff, and it takes a month or two. Then they've got to find a spot for you to go into the furnace, and there was we had one about 5 years ago where we'd done all of that, and the gas shut off after 4 minutes. There was a malfunction of the furnace,
It
and they couldn't get it restarted, and it became an invalid test.
it
oh
happens.
my gosh.
So you've spent a year getting to this thing, and all of a sudden it goes pear shaped. But it was just, and then you've got to make the phone call because everybody is sort of waiting at home, wanting to know how'd you do.
Yeah.
Yeah.
Yeah. You spent
Well,
three
it was
days.
looking really great.
Yeah. You spent days leading up to this, telling everybody how stressed out you are over this thing going down. And then it just goes sideways for something that you can't even is
Abs-
out of your control.
yeah.
And you're like, we have to do this again.
And it's a
Yeah,
long process.
and they try and help you out and do it, but you're still they can't bump somebody else off their furnace because they messed up for yours, and but when you talk about like the likes of Underwriters and Intertech, they're very expensive, but you kind of get what you pay for. Like you get knowledge that they're not going to put their thumb on the scale for you. That you know that while they're very expensive, they are backed by such a stringent adherence to the requirements of the standard and the building codes. They're very thorough in terms of coming to make sure that the product that you're making is the same that you tested. All of that, like, we know it's expensive and it adds a lot to the cost of the product that you supply. But the supply or the architect or the end user, they know then that they're getting product that has been very rigorously tested, and there's no small scale at UL. It's a full on fire test. It's 14 feet wide, 17 feet
Right.
long, fully loaded. It's a monster. Whereas it's not, when you're dealing with somebody like that you're getting all of what UL brings, and you're getting the technical experience that UL or Intertech or Factory Mutual will bring to bear. They are great organizations, as much as
Yeah.
we might grumble about them in terms of their cost. But
Yeah. Yeah. That's awesome. No, I think that you're right. We're dealing with lives here. So it's good that we have a very rigorous process and, we're not cutting corners. So yeah, I appreciate the notes on both sides, the grumbling and the saying, hey, you do get what you pay for in most aspects of life. So,
yeah,
but, yeah, we talked a lot about, kind of, uh, uh, ASTM and UL and some of these big organizations, but I'd love to hear more about. I know that you guys have been involved in some professional organizations. I'd love to hear about your community involvement and kind of above and beyond what you're required to do at your day job. Just being a part of the fire and life safety industry, both of you.
Sure. John, you want me to go on this, or I'm sure we
sure,
can go
yeah,
back
very
and
well.
forth on this because John and I are generally involved in all the same organizations over the years. When it comes to the sprayed fireproofing, I guess for the majority, you have your testing labs. They have their own, small organizations for all the suppliers. But the big one now that's been growing substantially over the past several years is the National Fireproofing Contractors Association. That's the NFCA. Where basically, in our industry, they're all specialized applicators. You don't necessarily want to give, everybody access to a life safety product just because there's a lot involved on estimating and building, the products and applying them correctly and so forth. They represent you, right? So there is an industry organization where they all get together, and there's a lot of training, different stuff involved. Manufacturers get involved, and it's a very good thing for any industry to have. In the past, I was part of fire stopping for a while. There's a similar one called the FCIA. Um, uh, so those are generally some very important aspects of any building or any construction material industry. One of the other ones that John and I are heavily involved in is ASTM. John's the chair on our main organization.
That's because I'm better than the face of it.
Wow, shots fired.
They do give me kind of a quasi sub chair of one of the things, but it's not really realistic. It's just kind of thrown in there that John runs the SFRM side for the most part, the cementitious fireproofing, and I've been kind of involved with the Intamescent side of it for the most part, trying to help develop a lot of standards. As John's job there is easy because he's dealing with a lot of existing standards that have been around for decades. There is a lot involved to update those standards, keep them current with the ever-changing industry code and so forth. But on the Intamescent side, we're kind of coming in from a clean slate, and we're trying to develop our own standards and sometimes piggybacking on some existing standards that are out there. That's kind of been my job over the last, I'll probably say 10 years. I'm sure many people would like me to kind of work on things a little bit faster and get things done. Unfortunately, I'm kind of working on my own schedule, but there's a lot in the background that's involved. Again, we're supplying products that need to be tested, and those standards also need to change periodically. There's a lot in that, and I'm sure John can probably add to those who are involved with ASTM, and the real big thing, and I know John, you would agree with me on this, is that we need to get more people involved, right?
Yeah. Absolutely. That's great. So to Phil's point, many of the standards that I look after, there's a couple that are referenced in the building code. So ASTM E605 and 736 talk about bond density and thickness testing of applied products, but there's a slew of other ones that are in there too that talk about how to test and provide test reports to your to the third party. So the architect or the building specifier or the product specifier will be looking for test reports, making sure your product is not damaged. One of the things that Phil and I have constantly been trying to do with the ASTM is that ASTM standards evolve and they change, and they change because products change, the methodology changes, the raw materials may change, the ability to test them changes. And it's sort of very frustrating to us when we make modifications to test standards. And there's about 600 people that get the test standards that we work on. And every 5 years, they have to be recertified. We make a few changes to the standard. There is a flurry of people commenting saying, we don't like this, we don't like that. Okay, well then tell us what you would like. Give us some feedback during the course of our meetings as to what we meet twice a year, but give us some feedback during our meetings. We would like this standard to change. It's very frustrating as manufacturers who put in a fair amount of our own time into developing and writing test standards, that you write the test standard, you submit it to the ASTM, they review it, make sure it's legal and current and stuff. And then you get people who come out of the woodwork who haven't bought an ASTM standard for 30 years, complaining about the fact that they can't get something done, or that they're trying to test the product to a standard that was written in 1986 when it's gone through 12 iterations since then. And we really like the testing agencies to get involved. The people who come along and physically do the testing of the products, they're the ones that are using these standards all the time. And as I said, it is kind of frustrating that when your applicator gets a non-conformance notice on a building because the testing agency has done something that hasn't been in the test standard for 15 years or 20 years. That can be a tough one. And To Phil's point, and I don't know what sort of your background is in terms of fire protection, Gus, but like not everybody can just rock up and buy a set of sprinklers and install it. You have to be certified to be an applicator. You have to,
Right.
you want people that are competent to be able to do this. And so the NFCA has been really making a lot of great strides in terms of and underwriters laboratories to qualified applicator programs, so that people who buy the product are qualified to install it. You don't want it to be like before, say in England, before Grenfell, it was like the two men in a van, right, was their reference. So that any two guys with a van and a ladder could show up, and if they wanted to install certain aspects of the fire protection thing, so cladding, not fireproofing, because they have a scheme there. But we don't want that. We would like to get away from that situation. So I know most of the big players in fireproofing will not sell to qualified applicators, people who don't know what they're doing. Whereas there are, we would really like to see greater adoption of, say, NFCA requirements for qualified individuals, that you can only sell and install to qualified individuals.
Yeah, I think that's an interesting point on qualifications. I think in general in the fire and life safety industry, something that it seems like a dynamic tension. Don't want to make it too rigorous to where it's a barrier to entry and people can't make it happen. But you want to get these situations where it's two guys in a van and these kind of fly by night operations that are not doing the right thing out as well. So yeah, I appreciate you talking about that, John. Um, yeah, it's very fascinating. You speaking about the professional organizations and kind of the broad goals and like trying to get people involved on the testing side, and seeing these standards change and evolve with time. I'm a little bit more acquainted with how the codes and standards process change, but yeah, like what kind of frequency do these testing standards change, if at all? I mean, I don't know how long have some of these been in place, the more common ones.
Some of them, some of the more obscure ones have been around for quite some time, and it's just a sort of revalidation every 5 years. We have a vote on it, and there are some people who will vote negative all the time because they have a particular slant or they want to see something included. But the commonly used ones, the ASTM E605, ASTM 736, even ASTM E119 and ASTM E84, they will change. We meet twice a year, every October and November, December, every October and every April. And they change, I would say, in about once or twice every 5 years. Once or twice every cycle, you will see a modification to it or a change to it, or a further adoption. So like as Phil said, he's taken on a whole slew of work with related to Intamescence. They change regularly. The difficulty sometimes is that it's a consensus. They're all consensus standards, and they are like in any like the on the sprinkler side, like NFPA 13 or I think you said your hangers is like ASTM or NFPA 409, right? Those NFPA standards tend to be a bit more rigorous. Like I'm on the NFPA 502 committee, and they're well attended and people are very invested in them. We would struggle sometimes to get more than 10 people at our ASTM meetings, and so
Wow.
the process we've before, like back in the mid 2000s, it would be just Phil and I staring at each other across the table.
I do remember that
conference room in Orlando. But now we do get it's much more heavily involved, and we do get a fair amount of comment via email about them.
Yeah.
But because they're consensus standards, the people can put the sort of kibosh to your development if they really want to. So if somebody objects, it can lead to a lot of so Phil has a standard in there at the minute, one of the inspection standards for Intamescence, and it must be on its 50th iteration.
Yeah,
and it's not it's not Phil's fault. It's just that every time you put something out, there's one vested interest or this vested interest who kind of throws the kibosh in and doesn't like the idea of shall versus should or something like that. And it can be sort of many times over the years I felt like throwing it in.
It's
Jeez,
definitely a
yeah.
challenge when it comes to that. I'm working on there's actually 3 practices being put through. I'm working on the cementitious SFRM practice for inspection, as well as the intamescent, and then there's also one being worked on in the background for boards and wraps. And anytime you put the stuff through, you think you finally got it, and it goes through ballot, and you always end up with some sort of comment. A lot of them are valid. Some people just have their own agendas. Some people have you change something one round, and then the next round they also comment on the change that they made, which is sometimes interesting. But we do run into a lot of it. It becomes a lot of politics, I guess, internally, and the goal is to make everyone happy. And when we're dealing with the inspections, you're dealing with the inspectors, you're dealing with the suppliers, you're dealing with the construction managers and the construction team. So we've seen a lot more attendance recently due to these practices, and we're getting close. I guess I've been working on it for about 3-4 years now, and if we can keep it under a year for it to get adopted, I'll be very happy.
Yeah.
I just want to get it all off my desk, to be honest with you.
Wow, that sounds like quite a struggle there. Well, I was gonna ask if you wanted to tell people how to get involved, but I don't know if you want any more chefs in the kitchen with trying to get something through for 3 years and having people with vested interests coming in and throwing a wrench in the plan. But
We're okay. The more the
yeah,
merrier.
yeah. So if somebody who's listening right now wants to get involved or is interested in hearing about the hearings or proceedings, how would you go do that? I'm kind of acquainted with NFPA, and how you throw in your kind of resume and into the pod and, be considered for standards and codes. But how does it work
It's
for some of these different agencies?
It's relatively inexpensive too, and essentially you just go to astm.org for ASTM. You go on there, and they have various different means for you to become involved. You could be, a supplier, an engineer, so forth. In fact, I don't think there's actually a specific requirement. To become a voting member and different things like that. That does vary, but just to become involved, and we would always suggest it for anybody. Literally, just go to astm.org and follow the prompts to join. You would essentially pick a specific. How do you want to say that, John? We have E5 and E6. So Codes and Standard Committee. So you have E5, which are the fire standards, and you have E6, which tends to be where we get into the different physical properties and stuff like that.
Oh, very good. Well, I appreciate you sharing that. Sounds like something I might want to get involved in and bug you guys more frequently about. But yeah, so I like to end these episodes with a little bit on just the professional development or the current kind of climate of fire and life safety. And you guys have talked about some interesting, different, common topics that are kind of impacting you in the field right now. Like John was speaking to electric vehicles and battery alternative fuel vehicles and how that's a challenge for tunnels. Or I had the thought of I don't know how you both are responding to mass timber or wood construction becoming more prevalent around the world. But yeah, I'd love to hear about what you guys are both seeing as trends in the industry. Sorry, not to seed the pot there with my own ideas on what I'm interested in.
Wood timber or wood timber, timber construction. Timber construction does have a concern for us, for any number of any number of reasons. The biggest thing, so there have been some fire tests that have been run detailing the use of timber that it will, it sort of sustain the ability to sustain the load. Nobody really cares about the temperature, right? Temperature is important, but if you're in a building, you're not really worried about how hot it is. It's really hot, but whether it's going to come down on you. And the thing that, like, the E119 as a fire is, it's used everywhere. Like, so whether it be here or in Europe or in the UK or wherever, it's the same fire test curve. It's slightly different in terms of the thermocouples that are used, but it's the same. And so they run it according to that curve, and there's very, very little leeway allowed in terms of how hot or cool it can get relative to the curve. So they either turn up the gas or turn it down, right? But it doesn't really reflect how buildings burn now. There's far more plastics in buildings than there were 100 years ago. The thing that concerns us a small bit, concerns me, is that when you're doing steel or concrete, you're not contributing any fuel to the fire. With mass timber, you're contributing a huge amount of fuel to the fire. Now you can get on and on and on beyond that and say, okay, well, we're going to do this and we're going to have a better sprinkler system and all of that. And the second thing that concerns me a small bit about it is this, that so anecdotally, we know that there are issues with respect to different products that are used. The glues that are made may not always be the same. So you're going to put them in fire-rated construction. It's not just a case of making them and putting them in. There should be fairly strict quality controls with respect to the types of glue that's used, the type of lumber that's used. So if you've got northern white pine, which burns really well, is it the same as having an 8x8 section of white oak? Probably not. It's not the same. But so there's all of this thing. It's just, okay, it's wood and it's fine. For us, the steel is all the same. A50, A36, they're all much of a muchness in terms of the fire resistance ratings. And we know we've a long record of it. I like the idea of wood. My fear is that as soon as there's a big wood fire, eventually there will be, that you're going to have a problem. I know, we see the NFPA magazines and stuff. Like, wood is arsonists love it, right? Even in my hometown of Waltham, Massachusetts, here we had a huge fire like 4 or 5 years ago, right? Wood building, almost complete, burned to the ground, and that's my concern. Is that you're going to have an issue with wood. That the first time there is a big wood building fire, you're going to have this big recoil away from it because of the fact that it's going to burn. Now, you can put fire retardants in there, you can do all sorts of stuff, but at the end of the day, the raw material itself is combustible. And I would like to see, I know there's a lot of vested interests sort of weighing heavily that it's the best thing ever.
Yeah.
I wouldn't live in one.
Yeah. I appreciate the exposition. Yeah. Yeah. What about you, Phil? What are your thoughts on trends? Or you don't have to double down on timber.
No,
I liked John's synopsis.
I mean, no, John covered that pretty well. I won't touch on that. John and I are both on the same page when it comes back when it comes down to that. So we'll have to wait and see, I guess. Some of the other big things is in terms of our industry is again trying to make sure everybody's doing the right thing. Again, there haven't been any revolutionary changes in fireproofing and the testing standards, but things evolve. John, I'm sure you'll agree with me here. One of the big things that happen, and I'm not going to cover it in detail because this can take hours, days, weeks to try to explain, but dealing with things like load restrictions. That's a big change that's happened in the fireproofing industry over the last 5 years or so, I would say. Making sure the buildings and the fire tests used are based on the construction, the steel that was tested, again, A36, A50. A lot of this involves restrained or unrestrained. We won't touch on that. These all kind of work together in making sure that the end user is putting the product on to actually meet modern building code. Because that's the key. Building code tells you what to do. They tell you the fire rating requirements depending on the individual building type, use, height, area, no matter what it is. It all comes down to that thickness that is put on that steel and the durability of that product that's put on the steel, making sure everything's following building code. And you just want to, John spoke earlier, John and I, that the people who install our products, they're generally a trained contractor. You don't want anybody getting in there. And typically, if anybody kind of walks in and says, "Okay, I'm now a fireproofer today, and this is what I'm doing. I'm now installing fireproofing," they generally weed themselves out after getting in trouble. Typically, expensive mistakes for them, and not only them, the general contractor, the owner. because ultimately their mistakes end up rolling down the line, I guess you could say. So again, the big thing is making sure everybody is getting on the same page, and load restrictions, full scale testing, proper patching. That's another big thing, is making sure you're using the proper materials to patch fireproofing. Um, each manufacturer has their own specific material, and the only items that can patch those materials are the same material or an approved patch. So that's all something that's changing slightly in the industry. It's been changing in the industry over the past several years. So, but besides that, it's a piece of cake.
If I could double down a small bit, or just sort of highlight another thing that I see, Gus, that is, it's a trend for us. It is sort of in terms of fire protection engineering. So it is not a widely taught discipline. Okay, and so I'm lucky that I live here in Massachusetts, and so Worcester Polytechnic is just out the road from me. And you've got Maryland, and I think Cal Berkeley and Oklahoma State do something, but it's not really widely taught. And so there's a real sort of lack of understanding within the fire protection engineering community about fireproofing, about the fireproofing that we do. So I apologize, but I don't know your background, but was there any emphasis at all? Because I know from talking to people who, graduates, fire protection engineering graduates from WPI, that they don't have anything. They don't do any fireproofing at all. Fireproofing of structural steel is not a thing. It's not taught there. It's not, as far as I know, not taught in Maryland. And we come across a lot of fire protection engineers, both Phil and I, and probably our colleagues in other companies, who have never had anything to do with fireproofing of steel.
Yeah.
And the thing that's kind of pushing, like one of the big macro things that's pushing in on this industry, is performance-based design. So we see a lot of sort of move towards that, where people are going to engineer the fireproofing out. They're going to remove the fireproofing in lots of areas. And a lot of times the engineers who are doing these analyses have no real experience with fireproofing of steel. It's a paper exercise. And we would probably, I think, like to see a little bit more education of the fire protection engineers to understand a bit more about the fire protection of structural steel, the fire ratings of foam plastic. That's where we play. There's a real lack of knowledge, not on education, obviously, but a real lack of knowledge of that area in what we do.
Yeah, I think that's a great point, John. I went to formal schooling for fire and life safety at Oklahoma State. So even in that program, I want to say, we covered the topic of fireproofing, but very, very limited amount of, knowledge. And, my background is as a fire protection engineer on the design side. And, I've been involved with like 400 or 500 projects over the course of my career. And, how many times I've gotten into the nitty gritty on fireproofing is infinitesimally small. So I think that you're right. We need to do better about facilitating this education piece. And I love talking with you guys about it, and kind of getting some more information out there for people who want to know about the subject. So I think that's a great point. But
Yeah, I mean, there are lots of people there are lots of knowledgeable people out there, but it would be great if one of the schools that's heavily involved in fire protection engineering, they'd maybe give a course. They tend to do it more like the structural steel, like the structural engineers, I think, do some of it. But there's not really, you get some people, Kevin Amalva, I think, has a joint license. But you really kind of, you don't see it that often. You don't see PESE too often. And they're the people that we would want to see doing a lot more of the work in this field.
Yeah, I think it's an interesting topic because across the nation, at least I can speak for the U.S., there's a real shift between who does the fireproofing or the fire stopping. Smaller to medium-sized firms might have an engineer do it, and maybe some firms have their architects specify building construction and fireproofing. And then and you kind of get everything in between that spectrum. Maybe some firms have the structural guy more involved or not involved at all in that option, other than to make sure that it's there. So yeah, I think you'd be surprised how many people and how many disciplines touch that fireproofing, or maybe you wouldn't be surprised. I don't know who I'm talking to here.
Yeah, I was talking to somebody recently, and they were talking about the amount of new fire protection engineers every year is so small. It's like 250 or something. I thought I saw that only 250 new fire protection engineers every year, which I don't really think goes anywhere close to satisfying the need.
Yeah. Yeah, I can speak to the program that I graduated from. We were only producing about 45 graduates, and I'd say maybe only probably a third or less of those go into actually being fire protection engineers. They might go
Yeah,
into environmental health and safety, or go work for a petrochemical company, and or do loss prevention for a FM or a UL. So I mean, yeah, I think that the need for knowledgeable people, as you guys have stated, is exorbitant. And if people want to get involved, there's so much opportunity out there for people who want to do the work and be a part of this process.
didn't Russ Harvey go to Oklahoma State? Was he in Oklahoma State?
I believe it might have been. Yes, he did. I believe it was Oklahoma State, and
So Russ Harvey is a colleague.
Yes.
He's a colleague of Phil's.
Yes, and the one thing that I'll add to what John said is, a lot of people, when they're looking for a career path, especially in a younger age, you're always looking for that niche industry, right? Fire protection is one of those, and you can the one incentive is it's niche. You can get into it, and you can make a good name for yourself, and you can be very successful at it. So that's one thing that I'll definitely say is get in now. We'd like to have more people involved, and it'll only make for a better industry and everything moving forward.
Yeah, it is a great industry to work in. Like, it really
It is.
does have a lot of really highs to it.
Yes, absolutely.
Yeah, I totally agree. There's a lot of opportunities, and for people who are good at what they do in fire and life safety. So that's awesome. Well, good to end on a promising note, but I would just wanted to thank you guys so much for coming on the podcast. I really enjoyed this episode.
Thank you very much.
Thank you guys.
It's great.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.